Time for our secants today. A secant is a line that intersects a circle in exactly 2 points. It's basically a chord that just keeps on going. Instead of being a segment, like a chord was just from one point to another point, just has endpoints on the circle. Now it just keeps going in both directions, so it goes through. So secants and chords are pretty much the same thing. It's really all there is to it. Well, we got a theorem about our secants. And really it works for a chord. If I read through this, it says that if two secants or chords intersect in the interior, so if they intersect on the inside of the circle, then the measure of an angle formed is 1/2 the sum of the measure of the arcs intercepted by the angle and its vertical angle. Oh boy, that was kind of confusing. So let's really think about this. So for example, I'm going to pick out angle 2 right here. So basically it's saying it's half of the sum of the arcs that it's formed by. Well, what are the arcs that it's formed by? This arc and this arc. Because here's my two lines, right? I got this line going and this line going. So it's formed by those two arcs. So let's think about this. So to find this angle, it's half of the sum of these two arcs. So basically it's the average of the two arcs. So to find the measure of angle 2, you would take half of the sum of those two arcs. So basically if I added the arc angle of BD and the arc angle of AC. It's basically just the average of the two arcs. So think about that. Average of the two arcs. That's how you find that interior angle in there. And so the same thing if I wanted to find the angle measure of angle 1 here. To find angle 1, I take the average of these two arcs, AB and CD, because that's what it's made up of. So to find the measure of angle 1, I would take 1/2 of adding those two together. So arc measure of AB and CD. It's basically an average of the two arcs. And then obviously vertical angles are congruent, so it works. 1 would be the same opposite and 2 would be the same opposite there. So let's use that here. It says find x. Well, if they intersect on the inside, which they do right here, to find this angle measure, it's just the average of the two arcs. So it's the average of those two. So I would take half of 88 plus 76 to find x. Well, if I add 88 and 76, I get 164, and half of 164 is 82 degrees. It's basically just the average of the arcs. Okay, well what if I am looking for something a little bit different here? So if I notice these arcs go with these two angles right here. So I could find those angles. So let's go ahead and do that first. Well, it's the average of the arcs again. So to find basically measure of angle, let's call this one right here, VZW. VZW. We would take 1/2 of 62 plus 96. So 62 plus 96 gives me 158, and half of 158 gives me 79. So that angle measure is 79 degrees. So I know this is 79. Well, if I notice here, to find x, it makes a straight line with that 79. So these two guys have to add up. So x and 79 have to add up to 180. So x plus 79 has to add up to 180. It should be what? 101. So x equals 101 degrees. Okay, so just use that information. So they intersect on the inside, it's the average of the arcs. Well, what if I'm not given one of the arcs now? So let's think you can do this mentally. I'm going to set it up the math way. So basically 60 is the average of the two arcs. So 1/2 of the arcs added up. So x plus 25. And I could solve this by algebra, right? So to get rid of that 1/2, I could divide by 1/2, which is the same thing as multiplying by 2. That's one, or I could distribute this. Distributing it makes it kind of sloppy. I'm going to multiply by 2 to get rid of this 1/2. So times 2, which means I got a times 2 on the other side. Because 2 and 1/2 is 1, so they cancel. And 2 times 160 is 120. And x plus 25. So subtract the 25 over. And x equals 95 degrees. Okay, a lot of us will do this mentally. And what you'll do is Since I know 60 is the average of it, you'll just double it, which is 120. And then you know that 25 and x have to add up to 120. So what number plus 25 gives you 120? And a lot of you can do that mentally and come up with 95. Okay, so if you can come up with your own strategy mentally, that's perfectly fine. Another theorem, if you have a secant and a tangent, their intersection would be at the point of tangency. So it would actually be on the circle. Well, this is just like a inscribed angle, basically, right? Because the vertex is on the circle, so it's got the exact same rule. So if I want to find the measure of angle 2, it's half of the arc. So to find the measure of angle 2, you just take half of that arc that it's made up of. So we'll take 1/2 of arc AB, or BA, however you want to call it. So same thing if I wanted to find angle 1 over here. It's the same rules, we just take half of the arc, because it's just like an inscribed angle. So to find the measure of angle 1, we just take half of arc ACB. Okay? Just like your inscribed angle. Looks the same except it's made up of a secant and a tangent. So we'll use that here quickly. So if I'm trying to find the measure of angle QPS right here, I know its arc is 250. So that means it's just like an inscribed angle, it's just half of that. So to find, I'll just write it up here. So to find the measure, it's just half of 250, which is 125 degrees. Pretty straightforward, just like the other day. Well, now it's asking for arc BCD. Arc BCD, which is out over here. Well, I know this is 108, so it's half of this arc. So to find that arc, I just double it. I'm at 216. And if I notice, the red arc and the blue arc make the whole circle, so they have to add up to 360. So to find that blue arc, we just take 216 away from 360. So in this case, we end up with 144 degrees for our arc. So basically this arc was 140. Okay, so not too bad. And lastly, if two secants, a secant and a tangent, or two tangents intersect on the outside, the exterior. So we did it inside, now let's do the outside. Then the measures is 1/2 the difference. So instead of 1/2 the sum, now it's 1/2 the difference. So, for example, they could intersect, all these intersect on the outside. So it's 1/2 the difference of the two arcs. So if you notice in this formula down here, you would subtract DE and BC, and it's just half of that to find the angle measure. And that works, in this case, there's two secants. It also works if there's a secant and a tangent. Okay, so to find the measure of angle A, you would take 1/2 the difference of DC and BC. And the same thing works if there are two tangents. Yeah, let's look at an example quick. So right here, they're intersecting on the outside now. So I know that that angle measure 62 is half of the difference of the two arcs. Well, I know what AD is, that's the big one, so 141, minus, well, I don't know what BC is, so let's just call it X. So you have a little algebra here to work through. And just like we did before, you're dividing by 1/2 on both sides, but that's the same thing as multiplying by 2. So we're going to multiply by 2, whatever we do to one side, do to the other. So that cancels the 1/2, and we're at 124 equals 141 minus X. So subtract your 141 over. And it looks like we have, well, negative 17 equals negative X, so X must equal positive 17 degrees. Okay, what a lot of people will do is, a lot of you do this mentally and you'll double 62 to get 124. And then you'll think, well, the difference of 141 and what gives me 124? So you're looking at 141 minus what gives you 124? And a lot of you do that mentally and say, oh, well, it's 17 degrees. So BC is 17 degrees. And last example here. So same type of thing. I can set this up the same way. I know that that angle on the outside is half of the difference of the two. So I don't know the big one now. So X minus 140. Well, if I look at this, do I really need to set this up? No, because this is 140. This is the rest of the circle. So I can just figure out 360 minus 140 to find the rest of the arc. So sometimes you don't even need to set it up. So 360 minus your 140 to give you 220 degrees. Okay, so just take a look. And in summary here, so we got our 3 theorems. Basically, if they intersect on the circle, just like they did for inscribed yesterday, and right here, it's just half of the arc, just half the arc. Okay, pretty straightforward. If they intersect on the inside, okay, remember it's basically half of the sum, or think of average of the arcs. Average of the arcs. And if they intersect on the outside, like they all are on these ones right here, then it's half of the difference. So basically, you subtract the big arc minus the small arc, and then take half of it to find that angle measure. Okay, so those are our 3 new theorems. That's all there is to it. And there you go.
Thank you, Mr. Etzel.